So let's create an array of doubles. And let's say that we think we're going to have 3 test scores. So we have an integer here of n, and we can set that to 3. So we think we're going to have 3 test scores, so we're going to create a pointer to test scores, and that is going to allocate onto our heap a new array of doubles. So we can store the test scores. And since you had to change your class format, the teacher has decided that instead of 3 tests, now we're going to use 6 quizzes. And so they want to update your test scores array and make it bigger. Well, we only can do that through dynamic allocation, and we are going to have to allocate a new array that is larger and then copy those scores in. So let me just fix this right here. We're allocating it the size n, and n is 3. So on our heap, we've reserved 3 spots, and we have a pointer test scores that is pointing to the first one. So if we want to double the size of our test scores, we're going to have to allocate a new array. We can't adjust the size of this one until we have, let's see, how do I want to say that? We want to create a new array because we have some scores in here already, let's say. And if we were to just say test scores equals new double of n times 2, we're going to double the size of the array. That's going to go pick a spot that has 6. And move our test scores pointer to this new location. And now we have no way to get our numbers out. So let's create a temp array. That is also a double star. So temp array is a pointer to doubles that is twice the size of our test scores array. So now this one is called temp array. And we haven't changed test scores, so we'll put the arrow back so that it is pointing at our test scores. So we have our original array that we allocated 3 spots for. And now we have a second array that we've allocated 6 spots for. Now we want to copy the information from this array into this array. Well, the easiest way to do that is to loop through. So we're going to create a for loop. Arrays always start at 0. And we want to go up to the original size. And then we're going to increment I for each time. Then we want to take our value from our temp array What I mean to say is we want to take the location from temp array at I, and I is 0 the first time. So this spot right here, we want to copy in from our test scores also the value at I. So the first time through, I is 0, and the 98 gets copied here. The second time through, I is 1, and so the 97 gets copied from test scores sub 1 to temp array sub 1. And then the last time through, it's 2, so test scores sub 2 gets copied into temp array sub 2. Now we don't need to copy anymore because that was just garbage, and now here we just have garbage. Now, we don't want to continue on using the name temp array for everywhere we want to use test scores. So we just say now that test scores is assigned the value of the temp array. So we move that arrow to point to here, and then we lose the arrow to here. Now we can treat test scores the same way as temp array. And yet remember how we need to release this memory. We haven't released this memory. If we were to double test scores again, if we were to go through this again in a loop, then we would have this whole chunk sitting there left over. And what happens is when you forget to release your memory keeps growing and growing and growing, and if your program runs long enough, you run out of memory and your program crashes. So we have to release this memory. But we only know where that memory is prior to reassigning our test scores arrow. So let's keep our test score arrow up there. We'll take out this call, and let's actually release our test scores first. Remember, we do that with the delete keyword. And we want to delete an array called test scores. Now this releases all this memory. It doesn't actually erase out the values, but the values are now freed up to be overwritten. And test scores is still pointing to that location, but that memory is not reserved. Now we can move test scores to point now to the same place that temp array points. So that reassignment right here is going to move that pointer to point to the same place as temp array. So now we've released the memory, and test scores is now pointing to this chunk, and we can move forward as if we hadn't duplicated the array at all. Now remember, I did say that you don't want to leave the pointer hanging, pointing to something that's not allocated, and then we assigned it to null pointer. We don't have to worry about that in this case because we've actually moved that pointer to point to something that is allocated, which is our temp array.